So I think it's 1:15, and we can go ahead and get started. Thanks, everybody, for joining. I know we've got a little bit of a big room, but if you want to get closer, you're welcome to. I don't fight. But what we're here to talk about today is how Firebolt, which maybe you guys have seen us at the booth in the Discovery Hall, and DBT can work together to unlock what we're calling low latency analytics. And so, worked a moment ago. And so what do I mean by low latency analytics? I think to explain that, I wanted to talk a little bit about how analytics has evolved. And this is going way back to before I was born, before probably a lot of you guys were. But if you think about the evolution of analytics, analytics really started with what we call batch reporting. So early days, first few databases, people are saying, okay, let's go in and figure out how do we give reports about our performance on a daily or monthly basis. Really low concurrency, relatively low complexity. And then kind of in the late 90s, early 2000s, we evolved into more of an ad hoc analytics scenario. So this is where instead of having that daily or monthly reporting cycle that gets sent out to maybe one or two stakeholders, you're now talking about, well, we want an hourly report, or we want something every 30 minutes. But these are all still primarily exports. So a lot of you guys in the room probably started your careers doing something like this, analytics engineering in a very ad hoc style. And then the last 5 to 10 years, we moved towards business intelligence. So this is where everyone was talking about, oh, the organization, the enterprise needs to become self-service. How do we make data available to everybody in the organization at the level of minutes or seconds? How do we enable everybody to work with the data and dig into it? And so we started creating tons of charts and dashboards and reports for everybody in the organization. And that's sort of been the scenario where DBT, Firebolt, all of these companies started to really make waves. But we're at an interesting inflection point now, where business intelligence in the enterprise is not really a differentiator anymore. Everybody does it. It's most of our jobs actually going in and saying, well, yes, of course we're presenting data to our stakeholders, and of course we're giving self-service. But where do you go next? And that's what we're calling data apps, or specifically low latency analytics. And this is all about providing that same level of interactive experience, but not just internally, but externally. So if, for example, you are a company that provides marketing services, maybe now instead of just reporting internally, you want to make dashboards available to all of your clients that show them in near real time how keywords are performing on Google. And so obviously, if you're taking that to an external audience, now things are more important, like sub-second latency. They want a consumer level experience where they change their charts, they filter, they aggregate, and the result returns immediately. You're also reaching a point where you have potentially very high concurrency. Thousands of queries, hundreds of users, all of this happening at potentially predictable peaks. And so this is sort of what everybody is trying to accomplish now, or hopefully you guys are trying to accomplish. And it's really driven by these main trends. So we're getting way more data in the enterprise. We're starting to try to differentiate around data applications or external-facing data products. And you're really trying to deliver on that millisecond performance SLA, where as soon as you do something in the application, there's a response for the end user. And then, of course, we all know that you can get speed and you can get high performance if you throw enough money at the problem. But we don't want to spend a ton of money. We want to do this in a very cost-effective, efficient way. And so if we think about the process of going about building one of these low-latency data apps, there's kind of 3 variants of this that we're going to talk through really quickly. So the first, I would say, is the V1 approach. You've got your existing infrastructure, probably a cloud data warehouse or your transactional database, something like Postgres, MySQL. And you say, okay, we've got all this data in here. Let's figure out what are the new use case requirements? What are the data modeling requirements? What do I need to create with DBT? Are there things I can reuse from my existing BI reporting and maybe leverage for this new data app that we're building? And then you say, okay, let's talk about architecture. We obviously care about supporting a large volume of data. We want ingestion to happen quickly. We want performance to be good. We need everything to be globally consistent and transactional so that our users aren't seeing incorrect data in their dashboard. And then finally, when we deploy this thing, it's externally facing, right? So it needs to scale up. It needs to be available, potentially 24/7. And we need to monitor it so that if there's any spikes, we can, adapt and make sure that we're keeping our services up and running. And so this is awesome. Seems super straightforward, nice linear line of things that you're building. You've got your DBT models in your Postgres or your Snowflake. It probably works well for a little bit. But over time, as your data app is more and more used, you start to encounter some challenges, mainly query latency. These solutions, transactional databases, kind of more traditional cloud data warehouses, aren't designed for sub-second query performance. So you're dealing with query latency of several seconds. You're probably reaching a point where the number of concurrent queries is more than your infrastructure can handle. So maybe you double the size of your cluster if you're in a cloud data warehouse. Maybe you torment Postgres a little bit and do something with read replicas and all sorts of nonsense. It starts to get complicated and difficult to serve that concurrency level. And then your cost overruns. If you're doubling your cloud data warehouse, you're doubling your cost. So the next evolution of this tends to be, well, how do we address those three problems? How do we go from that linear architecture to maybe something that's a little bit more fit for purpose, where we're now separating the two layers of work that we're doing? This is extremely common, I'd say, as the first attempt at delivering a true low latency data application. So the first two steps, you're probably still doing your planning, your use case requirements. Some of that is taking into account challenges that you encountered earlier, lessons learned, technical hurdles. The data modeling, again, you're looking at what are the transformations we need, what are the additional models we need to create. But now you're forking your architecture in two different ways. So at the bottom here, we've got what we're calling the processing data architecture. So this is serving your ELT. So running your transformations, your ingestion, creating all of those intermediate tables and models that you need to actually have as the backend for your data app. The top layer is what we're calling the serving data architecture. So if you're thinking of technologies that people tend to use, you've still got the cloud data warehouse or the transactional database on the bottom, but now you're layering on top some kind of an accelerator layer. So this could be an intermediate caching layer. This could be a technology like ClickHouse or Druid, something that's really designed and optimized for serving fast queries. And again, you're accomplishing your goals. You're solving that query latency problem because that top layer, you're now choosing a fit-for-purpose technology. It's designed for query latencies of seconds or sub-seconds, high concurrency. On the bottom, you're still using the power of that OLAP or OLTP system to do your transformations and to load your data. But you've still got issues. And I'd say they're exacerbated because of this split architecture that you've created. So first of all, your cost is higher. It's just as soon as you introduce more than one product, we all know this, you're now paying two vendors, and cost goes up. Your complexity is higher too, because the interesting thing with these two layers is now you're not necessarily able to reuse everything identically. Perhaps your serving data architecture has a different flavor of SQL than your processing data architecture. And so your DBT models have to look different. You're now maintaining two different pipelines, two different complete sets of modeling and analytics. And then the most interesting challenge that occurs that you wouldn't have had before is a consistency challenge. So how do you keep the data in sync between these two layers? How do you ensure that whenever you're updating your models, whenever you're building your new tables, that data is immediately available to your serving layer? Like if you're doing this marketing data app, and people are drilling in and trying to understand their clicks and their Google search performance, if they're getting new data and you're ingesting it every 30 seconds or so, but it's not updating in the dashboard, well, they're not able to make accurate decisions. You don't have transactional consistency, strong global consistency in that top layer. And so this is the point where I would say a lot of customers are struggling right now, a lot of organizations, is you've got this great vision, you've tried V1, you've got something built for V2 that you're probably decently proud of, because there's a lot of work that goes into this. This is complex, and we're all smart people, and this is, it's cool, it's fun to build. But if we really care about solving the problem in a cost-effective, efficient, easy-to-do way, we need one more go at this. And so this is take 3. This is, I would say, the vision for low-latency analytics that we hope everybody can get to. Essentially, you'll see we've compressed that processing and serving again. So this entire journey, you go from something simple with what you've already had, you add some complexity, you start adding fit-for-purpose tools. But now we're saying, how do you unify this? How do you get everything into one platform and focus on SQL simplicity, focus on low latency, and really efficient ELT with DBT? And so that is essentially taking Firebolt, our cloud data warehouse, and DBT, and using it for both processing and serving. So what this allows you to do is have that unified architecture. You get all of the benefits of a traditional cloud data warehouse. So that's the processing data architecture at the bottom. You also get all of the benefits of the accelerator layer. And that's happening in one platform that is using Postgres compliant SQL. So if you think of your DBT models, now you're back to that ideal state you had in take 1, where you have your models and you can reuse them and you can leverage them and take good models that are serving things in your existing processes and leverage that for your data app. And so this is actually what lets you, I would say, accomplish all of the goals of that initial data app. So you've got sub-second query latency. This is going to be incredibly fast. It also supports high concurrency, and it's cost efficient. Because again, we've removed the idea of having multiple vendors and multiple pipelines and many things to maintain, and we've simplified back down to this very nice linear world. And then finally, SQL simplicity. This is all using the same flavor of SQL. So you don't have multiple DBT models that you're adjusting based on very specific requirements for those different serving and processing layers. A couple of things to call out from a technological point of view that make this possible. These are kind of some of the Firebolt secret sauce, and you can, of course, come to our booth later and learn more about all of it. But indexing allows you to process much smaller chunks of data and get a lot of that speed. Compute, storage, and metadata are fully decoupled, so that gives you elasticity. And actually that ability to now serve the processing and serving layer out of the same platform. And then, since we've been emphasizing so much the importance of having consistency across all of your data, this is ACID compliant. And how does DBT fit into all of this? So if you look at the architecture, DBT is all about driving that efficient ELT on top of the warehouse. So Firebolt gives you the platform and the back end for building these data applications. DBT allows you to make the plumbing. You guys know all this, you're DBT experts. Everything in DBT, you can do secondary pipelines, you can do incremental materializations, you can control all of the different objects in Firebolt through DBT and orchestrate them. This is all through DBT Core. The particular adapter is available on GitHub, and you can pull it and start using it with your models. From the Firebolt point of view, one other thing to call out is the top line, where we've got no dependency on a particular style of data modeling. So if you guys like one big table, cool, Firebolt likes one big table. It's going to give you that same performance and high concurrency on that shape of data. If you're more of a traditionalist and you're into star schema and Snowflake schema, same deal. It's as efficient regardless of the type of modeling you choose. And so I do want to show how this works live. So what we've got here is an example of one of the data apps that one of our customers has created. So this is that search analysis and keyword research type use case. Everything in here is backed by Firebolt. So all of the clicks that I'm going to be doing, all of the charts that show up, this is all Firebolt. So if I drill in here, I'm looking at a particular keyword for a domain. This is Orange Theory. I think they're a gym. And you can see here, like this page loaded in a matter of seconds. I can apply different filters. So maybe I want to look at mobile traffic instead. Again, sub-seconds, we're getting all the results. I can drill down to different regions, same thing. Or well, if we paid for it, same thing. Under the hood, what this is actually running is this giant query. So we pulled this directly out of the query history for SimilarWeb. And you can see it's not a simple query. It's got some CTEs, it's got aggregations. We've got in here some window functions, array operations. Like there's a lot going on here. But if I run this query, it's completed in 0.25 seconds. Now, I know there's probably some skepticism about 0.25 seconds, like, oh, did she cache this? And for the purposes of this demo, we've disabled all result set caching. So this is truly just the speed of Firebolt on this data. The data set itself, if you remember the SimilarWeb app, this is running on something like 50 terabytes of keyword data from Google. And the interesting thing here is that Firebolt only needed to scan 240 megs of it. So that's what's making this so fast, is that we've configured indexing on the data that allows the query optimizer to know exactly what subset of data to pull. So I was talking a lot about low latency and high concurrency. So if we now look at, this is a dashboard that we created to just kind of visualize some of the charts that you're going to see. So if we now go in and say, start running that same query repeatedly. So the query you just saw, and I'm now just pounding the engine with this query. Again, all result set caching disabled. You can see here that the latency of this query is remaining around 37 seconds, even though I'm running the query over and over and over again. I'll try that one more time. There we go, 33, 37, 35. So you can imagine you've got a bunch of users in that application and they're all pounding on it. They're all submitting their queries. No one is getting degraded performance. The same is true when we actually take this into a concurrency run. So the interesting thing here is Firebolt allows you to scale to potentially hundreds or thousands of queries per second with practically no degradation in performance. So we're still seeing sub-second query performance on that giant query, even though we're sending through like 200 queries per second. If we go back into the app, what this is doing behind the scenes, the way that we're accomplishing this is through multidimensional elasticity. So we're able to scale all of our engines very specifically to support these different workloads. So that power run engine, where we were just pounding on the database and sending that query over and over and over again, that's running on one medium engine. The concurrency engine is scaled out in 3 different ways. So we've changed the size. We've made that node type a medium. We've added 3 nodes, and then we've doubled the number of clusters. So this is actually 3 times 2. This is actually 6 different nodes that's running to support the query. So you can see all of these different engines are operating against the same database, slightly different performance characteristics, depending on exactly what you're looking to do. The last part of this is actually data refresh. So if we start thinking about ingestion, this is where things get tricky with a lot of solutions because, again, you're updating data, you're refreshing your models, We were talking to someone yesterday with, multiple hours of DBT models that run and then needing to ensure that at the end that data is refreshed and there's no interruption to the end user experience. Because of that three-way decoupling that you saw, where we've got multiple engines all operating against the same database with different scales, you can actually do this. So I'm going to kick off an ingestion. What this is actually doing, and here's a little bit of the DBT fun, is we've set up an external source, this website's window v7. I'm just going to delete that. We've set up our website's window v7, and when I'm running this command, we're refreshing that data and pulling from our S3 location into our Firebolt database. And so if we jump back into the app, now that we're running this command over and over and over again, you can see that we're ingesting data at something like a rate of 1 million, is that 1 million? 1.5 million rows per second. And you'll see this takes about 30 to 40 seconds. And as soon as the full transaction completes, you're going to see the number of rows jump up. Now, as this is working, you'll see the number of rows on the other two tabs as well. I can go back into concurrency run or power run, and you're still seeing we're getting 34-second performance, even though we've got a really beefy ingestion job running on a different engine. And this is what's really magical and what really lets you compress those two layers in the second architecture into one. So we can, again, go back into the UI, see a little bit more of this. Our ingestion, here's that ingestion query that we kicked off that's running from DBT. This is our copy into that's been generated. If I go into the concurrency, you can see we're kicking off, this is like 500 queries that are all running at the same time, again, with that 200 millisecond performance. And on our Power Run engine, I'll show you the observability metrics here. You can, again, see all of those queries starting to come through. So all of this performance is supported by that ability to have engines for different workloads and scale them independently. The other thing that you can set up with DBT is, of course, I showed a simple ingestion in that demo. So just doing a very basic insert. But you can also support some of these incremental materializations. So get a lot more complex and say, well, maybe every 30 seconds we don't want to drop and recreate the entire table, but we want to just grab the most recent data from that 30 seconds. So this is an example of the SQL that we've put together to populate that website's window v7 secondary table. We're doing some aggregations, we're doing some maxes, but the real magic in here is operating off of source file timestamp and finding that delta. So all of the functionality that you guys are used to with DBT and that you like having for more complex use cases is fully supported with Firebolt. So really the things to emphasize here, again, how are you able to support that low latency data app experience? It's through the solution where you've got one platform for serving and processing with DBT for all of the operations in the inside. So if we look at this simplified architecture diagram, we've got DBT driving all of the ELT and all of the processing, and then Firebolt in the middle serving the data for both creating those ELT pipelines and serving your traditional BI workloads and your data app workloads. The database itself, Firebolt, is going to allow you to really have that high concurrency, low latency experience because of the architecture that lets you spin up multiple engines, decouple storage metadata and compute, and really specifically index your data. And so the big takeaway here is if you want to really deliver on the vision of a low latency data app, you can now in a way that you weren't able to before. I think one of the keynotes yesterday was talking about unification and the ability now to start pulling everything into a single platform instead of having everything disparate. And that's really what you can start doing here as well, is pull together all of these different layers, unify them with DBT, unify them with a single data store, and serve both a traditional use case and that really exciting new data product. So with that, I think we've got 5 minutes if anyone has questions. Yes? Mm-hmm.
Data warehouse solution. So as a niche, what you're targeting, since low latency for very few people versus a lot of team you can talk there and we talk building some back solutions. So if anyone wants to move firewall, is it only because we have to achieve low latency or is it with batch processing? What is your vision there?
Yeah, so everything Snowflake can do, Firebolt can do too. So, I mean, I know that sounds trite, but I do actually believe that. We're trying to take all of the best features of like a traditional warehouse like Snowflake. I know it's funny to call Snowflake traditional, but they are now. And then layer in this extra piece of really giving you that high performance, low latency. So are we good at ETL? Yes. Are we good at batch processing? Yes. Are we also good at the data app use cases? Absolutely. The cool thing is we kind of coexist with Snowflake and some of our customers. So because Snowflake, like, there's not much wrong with Snowflake. Like, it's a good cloud data warehouse. It just can't do this second piece. And so people come to us and say, hey, we've got that V1 architecture. We've tried to serve our data app out of Snowflake, and it's not scaling. Like, we're using the biggest cluster size that they have available. It's super expensive. It's still kind of slow. How do we solve that? And that's why they're at least starting to adopt Firebolt. We also have people who are coming from Postgres, and they're like, we want a cloud data warehouse that does everything. And then those people also pick Firebolt. Yes?
Differentiate Firebolt from Terra Data, which also has the parallel processing and multiple nodes and have different
So I'll be totally honest, I'm not super expert in Terra Data. It's been a really long time since I used Terra Data. My suspicion would be similar to Snowflake. It's this data app serving layer that it's not optimized for. So it's going to be great at being a warehouse. It's going to be great at being OLAP. But in terms of serving that near real-time, high-performance experience very cost-effectively, that's probably not going to be its strength. Again, I'm not a Teradata expert, but that would be my guess. Yeah, so that's DBT. So like that's one of their core things. Yeah. Yeah. Yes. Mm-hmm.
But cost is kind of immense.
Yes.
Scaling to the large graph sizes. So I'm curious, like, can you talk a bit to the cost difference?
Yeah. Yeah. So what we've seen, and I think our marketing team is in here, so I don't know if this is what we say, but what I've seen with some of the customers I'm working with is like anywhere from 3 to 10x cost difference between Snowflake and Firebolt. And the reason you get those cost differences is twofold. One is the indexing. So if you just look at a single engine-to-engine comparison, like a small in Snowflake and a small in Firebolt, just the raw price might be the same, but because of the way you're able to run queries way faster and process less data, you can stack more queries up onto that small engine and support a higher volume and a higher concurrency on that engine before you have to scale. So that's one way that this can be cheaper. The other way is in that the more complex or more robust scaling capabilities. So if I look at our engines here, there's actually 3 different levers you can pull to adjust your cost. So Snowflake does a lot of doubling. So you take a small warehouse, you double it, you go to a medium, you double a medium, you go to a large. Here you could say, well, maybe I don't need to double to a medium, or double from a medium to a large. Maybe I can do 3 small nodes, and that's going to be cheaper and get the same performance. Or maybe I'm just going to add a second cluster of 2 smalls, and that's going to serve the number of concurrent queries I need. So you have a lot of granular control.
So do you offer pricing by byte scan and stuff like size?
So pricing, you can see it here. It's like super simple. It's engine uptime measured in seconds. So you are paying for the compute you use, and that's it. So again, really trying to be that unified platform, but very cost effective at giving you the performance you want. All right, I think we are at time. So I'm happy to take more questions here kind of as we switch speakers. We're also at the booth. We're like a big red booth with the data challenge. I think we'd all love to see you guys there if you have more questions, more comments. But thank you for spending 30 minutes with me, learning a little bit about this. And yeah, I hope you take something good away about how you can evolve into making some of these really exciting data apps. Thanks.